Welcome viewers. In this video we are going to do design of warehouse structures. So this is part 1. There are 8 number of parts which we are going to look into that. So in the first part we are going to do structural modeling with the Eurocode in robot structural analysis. In the next part onwards we are going to look load calculation, load combinations, moving loads and load application to model, member design, connection design, and finally secondary member designs like purlin and side rails. So these are the 8 number of parts which we are going to see in upcoming videos. In this video we are going to look about how to create the main column, wind post, rafter beam, tie beams, roof and wall bracings, crane beams, roof and wall claddings. So let me look into that model. You can see the 3D view of warehouse building which we are going to do demonstration on this video. So this is having 30-meter length and 18-meter width, having a 12-meter of height from floor to the eave and 12.8 meter from floor to the ridge, which is showing the dimension here in the left and the right. Also this length is going to divided into 6 number of bays of having 5 meter wide, so that the 5 into 6 is 30 meter, and again in the width direction we are going to divide it into 3 bays of 6 meter each, so that 18 meter can be achieved. Also this warehouse is having 3 number of openings. One is a rolling shutter which is at the middle, having a 6 meter wide and 9 meter height. We are going to make it in model. And also to the rolling shutter left and right there are 2 number of doors of having a 2 meter by 3 meter, which is to be used for the passage and maintenance purpose. So this is a model which we are going to develop in the robot. Now let me look into that robot structural software, and this is a landing page of the robot structural analysis. Click this new, so that you can able to see these various icons. In that, from the top right we need to select the third one, frame 3D design. Go to tools, set the job preference. Job preference is nothing but we are going to define what is a material and what is a standard to be followed. Here we can select the British standards. So what we are going to do is we are going to use the materials based upon the British standards, like universal beam, universal column, UB and UC profiles, with a grade of steel grade of S355. It means the yield strength of steel is 355 for the thickness less than 16 mm or something, or else it can be reduced by 10 Newton per millimeter square, 345 Newton per millimeter square. So that's depend upon the thickness of member which we are going to select. So here the British we are going to select, and the load we need to select this Euro, which is already added in the list, and the standard loads already there. And coming to the design codes, we need to add the code combinations, so which we can also search whether it is a British standard with the European nation is available or not. Yeah, it is here, so we can add it here. Click OK. And the snow load also we can check. If it is not there, it is better to have same value, because the snow load we are going to calculate and apply on the structural model directly, and here we are not going to consider any seismic load, so we can ignore this and just save current parameters as default and click yes, click OK. Now our robot screen is ready for making the model. So once this job preference is fixed, then we need to go to the members icon in the right hand side, click that, and see here is a W16 by 40 is there, it is, which is a American material, American standard material. So we need to go for UK selections, and with that we do have some confusion whether we need to consider universal beam or universal column. So universal beam we need to select it if it is the height of the warehouse is more than 6 meters. Generally this UB will have more stiffness and deflection compared to the column, but however the weight will be higher when compared to that column sections, universal column sections. So our case, the warehouse is having a 12 meter with various moving load also, so it tends to subject to deflections in width, length, depth direction. So we need to have some deeper beams, So for that we are selecting the UB, and coming to that section profile, generally we can select height divided by 10 or 12 in the range of the sections, so that the depth can be safer. So at present we can select 533 by 210 by 82. So here in this we are going to do some iteration method. If this 533 is okay with the optimized design, we are going to follow the same, or else we are going to reduce. If it is unsafe, we can able to increase that, or we can do some rearranging of the frames. So this is what we are going to do it. And the column sections, we are here in the UB 533 is nothing but it is a depth of the beam, it is a top and bottom dimensions of the eye profile, you can see here. And 210 is a width of the flanges, and 82 is a weight per meter of the sections which we are going to select. So generally this will vary according to the web and flange thickness. So this is a British standard section. So now the grade of material also it is S355 which we got assigned. Click add OK and change this to WB 533 210 86, and this column is going to start from 0, 0 coordinates, and it is going to end in 0, 0 in XY panel and XY face, and 12 meter in the height, that is floor to eave. Adding this, you can see here, it is here. Not only that, if you see this profile by clicking this view icon, the section shapes. So this shapes is parallel to the length, the depth is parallel to the length. Generally this parallel to length, there we are going to provide every 5 meter once we are going to provide the column, so that also we are going to provide with a tie beam. So the maximum the deflection in this direction is very less compared to the width direction, because in the width direction we are going to keep this column, another column at 18 meter. So it is better to turn this column to 90 degree as like here. So you can see here it is turning in the 90 degree. Now what we are going to do is we are going to make another one column in the other side of the width. Select that beam number 1 and go to edit, move or copy. Select the node 1 at the base, and here type 0, 18 meter we are going to keep, and 0 in Z direction. So now you can see we have developed another one column which is also in the same side. So now we are going to create the rafter beam. Click here again member. So here now we are going to create beam. Go to this. So the beam also we can have the same thing, instead of doing selecting everything. And the beginning of this beam we can connect here, and another one we can connect here in the fourth node. So now we can see that there is a flat beam, but we know that ours having a inclined of 5 degree, which is ridge is at 12.8 meter and eave height is 12 meter. What we can do is we need to split this beam. So select this beam and go to divide. So in this divide we need to mark it as into n parts and enter here 2 and create nodes without member or edge division, but we need to create this with breaking of the beam. Click execute. Now you can see this. So now what we can do is we can select this node number 5. You can find here it is a 5 is selected, and just enter this coordinates height into 12.8, so that you can able to find this. So this is how we need to make this rafter. So again this rafter is having the depth in the maximum dimension in up and down directions. Now we need to add the support conditions. So click in the right hand side icons supports. Generally this warehouse column to be designed as a portal structure, so it should be pinned at the base. So we are fixing here. Now as the width is having a 18 meter and the total span is having a 30 meter, we need to split it into every 5 meter interval. But as it is having a more width 18 meter, there will be a possible of movement, maximum movement causing at this fixed point, two fixed point at the end of the rafter and at the middle of the rafter. So we need to develop a haunches in this. So in order to make the haunches or the brackets, just to go to the geometry, additional attributes, click additional attributes, go to the brackets, so that you can see here a small window, brackets, and here already by default we are having these bracket values. So here the bracket we need to define the sizes. So the member width, member length, we are knowing that 18 meter is divided into 2, so 9 meter. If you are entering that 0.9 means it will consider 0.1 into 9 meter. So likewise we need to provide the input. So as it is default provided, we can have this. So once after selecting this, you just select this beam and this beam also. Now you can see the haunches are developed. But for the 18 meter, if we found this is very less, we can also change here at any time, so that this will vary accordingly. So now again for mid of the ridge also we need to add these haunches for better movement transfer, because as you know this for portal frame the maximum negative movement will occur in the end of the beam which is connected in the column, and the midspan movement is at middle. That is why we are consider this like haunches. Now one set of column is ready. We are going to create this to 30 meter by just making us selecting this object and going to the edit menu and edit, move and copy. Select the first node and type here 5, 0, 0. Similar like type 10, 0, 0. Okay, minus 5, 0, so that it will come between the two columns. So now this can be 10, so accordingly we need to create this. Now all the 6 bays are created for 30 meter length. Now we need to introduce the wind post. So generally for the rolling shutter purpose we are going to introduce the rolling shutter column at this area, which is having the height of 9 meters, so that we can break this beam into 2 and keep the one more wind post column at this location at the middle of the rafter. So for that, go to by selecting the rafter at the left hand side of the width, go to the edit and go to divide. So again parts into 2. So here we no need to break the beam, we need to just create the node at the middle of the beam. So this should be selected or tick. So now you can see there is a 2 number of nodes are created. Now we can again do copy paste, selecting that 2 node and edit, move and select this node, and we can select as 0, 0, 0 minus 12.8 meters, so that this node can be created at the bottom. So anyway it is gone somewhere. Now we need to select this node so that we can able to find out under X and Y direction where it is located. Then we need to create one more node which is to be connected for the wind post. So the same X and Y we are going to define here, but instead of height 12.4 meter we are going to select enter here as 0. So similar pattern we need to do for this side nodes also. now we can add a wind post by clicking the members, and this time we can select another one profile. So this we can select as a column. Generally that wind post is not mostly subjected to maximum deflection, so we can select UC profile. So in that UC profile we can select some 356 with weight of 153. So this we need to connect this way. So wind post is in correct position, this directions, and one more wind post we need to add here in the end of the width in portal, similar like the same. So now the wind post is added, and similar like we need to add the support condition also. So for the reactions, now we need to add UV tie, same members, but this time we can select a lesser dimension beam, UV beam. So here 178 we can consider by 19, adding here, and we need to draw from here to there. So after adding the UV tie beam, then we need to take a section of this portion to make the rolling shutter and door columns. Click this icon, edit new window. So select all this column and go to edit, divide. So here we need to make as a distance. So every 3 meter height we need a node in this all the 4 column in order to connect the door beams. But however this side it is going up, so we need to make it as, select this node and just type here as 3 meter, so that it will come down and sit on the column. Now we need to select this 2 column for rolling shutter. Similar like we need to divide it with the distance of 9 meter. So as we know that the height of the rolling shutter is 9 meter. So again it is going in somewhere here. So we need to select it, type this, because why this is forming in different way means the starting point and end point of this column are different. So we can change that by typing here itself 40 and 37. Similar like 39 will as a start point and 36 will be the end point. So like this we can create. Now we have created this, and we can also add some beams. This time we can add a PFC, that is channel profile. So this will like C-shape profile. So for door beams we can consider 260 by 28. So connect this. Similar like do it for rolling shutter we need to select a heavier beam, which can be in the depth of 300 and more. So we can select the UB as 300 in the range of 300 and okay, we can select as 300 and by 40 section or 42 sections. Add it here. So now we have done this, but however the door width is very less compared to this distance. This is a 6 meter we have considered, but now it is going to reduce. We decided to go for 6-meter wide rolling shutter, but unfortunately during the model, by taking the middle of the node, it is coming to 9 meters. So let we consider the same as it is for the demonstrations, and we need to add some 2-meter distance, 2 columns at the middle of the beam. So we know that 4.5 meter is the width of the column, so we need to divide this into accordingly to the distance. So what we have done is the similar way we have created the column for the door also at 3-meter height. So far you can see that the section which we have selected is 152 by 23 of UC profile. So this is what we have now developed the rolling shutter and door frames. Now we can exit this selected views. The bracing. So for that we need to select this and create intermediate node. So we are going to split this into two, that entire height, so that we are going to provide the 2 level of bracings. So for that select that and go to edit, divide, n parts, 2 numbers. So again this need to select generate nodes without member or edge division. Now select this right hand side icon for member. So here we need to provide angular L sections. So here again we need to change this to UK sections. Angle we can consider 100 by 10. Add. Now we can draw from here to 57. Similarly, we need to add a tie beam here in horizontal axis, that we can consider as 178 UB, 178 10 108 by 19 as a horizontal beam here in between the two panels. So similar like we need to create for all the base also. We can do like a copy paste by selecting all these newly created members. Go to edit, move or copy. As we are having a same equal span, you can just copy paste. So similar like we need to do it for the other side also. We can select this left hand side longer span bracings and tie beams and go to edit, move or copy. Select first node and the second node to copy and paste this entire bracings. Now we need to create the bracing in shorter directions, similar like the same method. In the shorter direction we have created the bracing like this, N bracing in shorter direction where the rolling shutter and door is coming. And other direction that there is mid wind post, in these directions we are forming the X bracing. Now we need to create a bracing member in roof. Cut this view. So here what we are going to do is we are going to add a tie member, horizontal tie member on the rafter from 1 meter from the ridge on both sides. So first we need to check whether these members are start with which number. Okay, that 5 is the first number. So likewise we need to select all this. We need to add a node here. select all this Rafter member, go to edit, divide. So here distance we need to create as 1 meter. So once these nodes are created, then we need to create the nodes in the other side raft. So select this, and before going to add the nodes, we need to check the dimensions at what length we need to break it. So if you take this inclined dimension, it is showing 9.04. So from this end, if we need to break 1 meter, means as the starting point of these members are in left hand side, so we need to enter the dimension from the left hand side. That means go to edit, click divide. So in the distance we need to mention here 8.04, because the length is 9.04. we need 1 meter at from the ridge, that is right side. We are going to enter the dimensions from the left side, because the member is start from the left side node. Click execute. So you can see there are some nodes added here. You can also measure these dimensions, 1 meter, and this side also it is 1 meter. So now we need to add the member, that is tie beam. Just simply click here. As this is a equal span, you can just copy and paste to the next. So now again we need to break this rafter for tie beams, X bracing or V bracing we are going to add here. So now again you can select this all members, and here we need to provide a mid nodes. You can leave this, already here mid node is developed. Go to edit, divide, number of parts is 2. Okay, in this we are going to add the V bracing. Select angle member. Now here we need to draw this. Select drag also, so that the continuity will be there. So we are adding here V bracing. So we can copy and paste to until the mid bay. Now this to be mirrored, you can select all the 3. After selecting the V bracing which are going to mirror, go to edit, vertical mirror, click this, select this node number 15, that is in apex, so that you can see mirror of the bracings. Now we have created the bracing member also. Finally we need to create the cladding system. So let me close this. So that cladding panel we need to create now. For that, go to geometry, select here claddings. Always it should be one way X direction. Select rectangular. Select this any 3, so that you can able to see the cladding. Similar like select for others also. So once after creating in one bay, just copy and apply these to all the panels. To create cladding in width direction, cut these sections for view. So now again go to geometry, cladding, rectangular you can select for this. And for this one we need to select a contour. So contour used to have always close to points. So this panel is not exactly at the node, so select this part and drag this. Similar like this part also not close to the node, so drag and fix this. So similar like draw the panel for this portion also. So for now we have created the wall claddings. So let we view this in 3D. So here now missing is only the roof cladding. So for that select the roof panels, edit in new window. So here keep this as a plan view and start draw cladding. Go to geometry, click cladding. Again this is in rectangular, you can select these nodes. Similar like for this portion also you need to select. So after creating the one bay, one claddings in one bay, so just copy paste by selecting this and go to edit and click edit to copy. Similar like select the first node and the second node. Now all the roof cladding and wall claddings are created. So this is our model view. And before that we missed one thing. We need to create the crane beams. So let we hide all these claddings by clicking the view. So we are going to create the crane beam in longer direction. So select this two view and go to edit in a new window, view in a new window. So you can see here these are the two longer side panels where we are going to break the column nodes to generate nodes for the crane beams, and we are going to draw the crane beams. For that we need to select all the columns which is required to be added for crane beams. Go to edit, divide. We are going to fix this crane at 9 meter. So type here as 9 meter so that the nodes are created at 9 meter. Now we have created the nodes at 9 meter in the column. Now we need to create one more set of nodes so that it should be at 1 meter away from the column in order to create the corbel beam. So for that select the node this left hand side column and just go to edit and move or copy. So in the transition what we are going to do is we are going to select this first node as 138, and we are going to type here, it is going to extend in y direction, so 0, 1, 0, and click execute, so that you can see a set of nodes at 1 meter distance. So similarly, like select this side also, again create edit, move or copy, and select any one point node here, and type here 0, this time it is -1, y is -1, execute, and you can see there are offsetted nodes to create the crane beams. Now it is simple for us to create a corbel beam. Go to members on the right hand side and select some deeper beam. You can select 355. If you are not having, you can go to this and select that UB 356. This can be a suitable one. Add, and we need to run this by connecting these two nodes. It should be start with 126 to 140. So the same corbel beam we need to apply in all the newly created nodes. For that we can do like edit, copy, paste methods. We have added all the corbel beams. Now again we need to add the haunches for this corbel beams. Go to this geometry, additional attributes, and we already saved some brackets type. So the same brackets type we are going to apply for these haunches also. Select here, strongly selected. We need to select the end this side, so that this will create at this portion. So likewise we need to do it for all the other corbel beams also. After these brackets, and we need to add finally the crane beam which is running throughout the length of the beam. So again we are going to add the same section of beams. We need to just connect from this 146 nodes to 140. So similar, the same way we are going to do for this side also, right hand side. So now with this we have created all the members including the claddings. So this is what our model which we have generated in this. Look description for more related videos. Subscribe to this channel for more updates. Thank you.